Hello, this video is going to be a Calypso introduction to get us acquainted with what Calypso will do and how we'll get it to allow us to program offline so that we can then take our program and inspect our part at the CMM. Again, we have no password at this time, so OK. Launches the software. Here's our tip. Just close it and move on. We are going to open an existing plan. Our two choices typically will be create a new measurement plan if I'm starting a new program, or I'm going to open a measurement plan. In this case, we're going to open a measurement plan. You're going to navigate. There is a default folder that it puts stuff. You really want to get in the habit of navigating and sending it to a particular spot so that you can find stuff. It's going to create a whole bunch of files in a folder with the name of whatever you save it as. So here we are. So you need file management matters. Let me just put it that way. All right, so inspection files. We're going to look at the NIMS grinding part. Now I did find out the hard way that if you do file save as something that already has a name, it adds to the last number if you have a number. If you have no numbers, like here in the CNC turning, it's just going to do 1, and then the next time you do save as, it's going to do a 2. It automatically adds these things, and sometimes you're going to have to watch your file names because I had up to year 19 already, so I can rename the folder and that works as long as it's already closed, but just be aware file management matters. So I want, this is my latest and greatest NIMS. Open that folder, and then there's an inspection file. See what I mean? There's a whole bunch of files in here. There's files inside of here with all kinds of info. So it defaults to the inspection name, inspection type of file. So I'm just going to open it again. It's going to load my file here, and it looks just like CAD because it is. The mouse clicks left, hold down, drags around, right will rotate, pivot, turn around. It's pretty easy to get it all messed up. Wheel zooms in and out. Down here at the bottom are some really important things. Here I can shade it or make it wireframe. And over here is a choice where I can pick my views if I want to look at it from the top or if I want to look at it from isometric, which is pretty typical. So important thing to know when I pick and I start building all of this stuff, I want to define select geometry. Define and select geometry is really pretty much the option I want to use. We don't need that right now, but just in case I forget when we start talking about things. So this plan, this one is done. So whenever you're making an inspection plan, you always start from the left. There's these 4 tabs up here, and then they have stuff inside of them. But you always start from the left and work your way to the right. That's the easiest way to go, answering the questions. Yeah, I'm going to get rid of my picture here. We don't need to look at me. Oh, okay. I still see me, but it says hiding. Okay, so I start with my CMM settings. We've already gone through how to do this, so once it's set up, we do not need to do anything like that. Stylus Systems. We have several different probes, and if you watch the other videos, we have to come in here to do a tool change and some different stuff like that, but this is a manual tool change, so I can pick this, pick up a Stylus system, and I can choose which I want. And we have three. We have a 3mm by 50mm straight probe. The master probe we use to qualify the system, so when we're programming we don't use that. And a star probe. So if I have something I need to get in some funny different ways, I would use a star probe. But typically we're going to use a 30 by 50. So you always want to make sure that that's set up. We can go ahead and close. So as I work my way across, I answer these questions. I have to do a base alignment. We'll get into this a little bit later in detail. I have to set clearance planes. I have to choose the kind of printout I want, and we've made a custom one for South Elgin High School. And I work my way down this list. I go over here, characteristics. Now, a characteristic is basically a rule that you put on to a feature. So the first two we do, but then we're kind of going to work with features. We have to define a feature before you can apply a characteristic to it. So perpendicular, I have to, it says perpendicularity plane 1 to A. Okay, so I pick it, and here is plane 1 and here is datum A. So I can't actually set a characteristic until I create a feature. I had to create datum A and plane 1 in order to make a perpendicular characteristic. Now it gets kind of challenging because you need to know, how do I know what characteristics I need? And I know that by my print. I have to look at my print. So everything that's dimensioned on this print needs to be in the measurement plan. Height, width, length, where's the center line of the slot, how wide is my slot, oh, true position within 3 thousandths to datum C, datum A. So I have to label my datums, A, B, C, perpendicular. So you start with the simple ones and then you work your way through. If you have holes, it's a much bigger to do. Okay, so let's go back to our thing. Just kind of giving you a little overview here. So we created our features, then we created our characteristics or our rules defining how my part has to be and the tolerance that goes along with it. Once I think I have it done, I'm able to simulate this running and inspecting. So let me tilt this a little bit, move it over a little bit so we can see. And the way I can do that is I can go up here to Planner, Stylus System Simulation. And so this other window pops up. And there are some typically when you hold this you can get your, well, I don't know, we used to call them tool tips or flyouts, but they're not on. So they can get that by going over here to the question mark. They call it bubble help in Zeiss Calypso software. So now if I come over here, I can hover, check measurement range, collision observation, show the Stylus system. So if something's missing, I can see it. So simulation's ready. I have to go over here to run. Okay, I want to clear existing results. That way I will, if there's some old things in here that I ran before, I won't see it again. And press start. Typically I don't want the speed too much more than about halfway. I want to make sure it gets all the data. And this thing's going. It's checking this bottom surface. I'm going to turn it up just so this isn't like forever long watching this. But it goes through and it's checking each of the surfaces according to the measurement plan over here. So it's inspecting the datums the way that we told it to inspect the datums, or the features I should say, and then it's going to give us a report on how we did with these characteristics. Let's speed this up a little bit faster. And it actually, when it's done, it will give us a report. Now obviously in just simulation, when I'm inspecting a part, that is no different than how we designed it, we should get nothing out of tolerance. So we'll go along here. We don't have much time left. It's almost done. I want you to see the report at the end of this. So ultimately, like this is not a whole lot different than writing a CNC program. I'm not doing G&M code, but there's a process to it. You have to create the geometry. So we created this 3D model in Inventor. Now this block on the bottom is what I have developed as this is our theoretically our table, so that we can sit our part directly on the table and get some data off of it. So it's a 6 by 6 square. So it's here comes my report. We made a custom report for South Elgin High School, and let's make this a little bit bigger. And so I have this report. It tells me this is the name of my inspection plan. So I would put my part name in here, a little more detail, your name, our course, and any notes that you want to put to let the teacher know that things are good. So you know, no emojis here though, right? We'll have to fake it. So anyways, so this could be my first time through, so I notice I have everything is green here. That means it's in tolerance, but this tells me the value that it is, what's the nominal value, what's the upper and the lower tolerances, and it'll tell me how much out of tolerance it is when you run it on the actual machine. So when I'm doing a simulation, it better be all green or else there is some sort of a problem. One of the other things that's really nice about this is if I had a collision, in other words, I was probing over here and I went straight through the part, which in a CNC machine would cause a bad crash, break the thing in here. We'd break this little stylus and we'd have some problems because I don't have any other stylus. So it will let us know if there's collisions, and then we can go and fix them up. But that's just kind of here's an intro, what we can do with it, and in following videos we'll go through how to set it up and how to start programming this. All right.